This video is a review of the Telstra Smart Wi-Fi Generation 2 booster. In the box you get a quick start guide with some handy hints, a safety leaflet, the booster, and a power supply. To set up booster, just connect booster's power and switch booster on. Then wait for front light to turn red. The label on the front of the booster is not normally there. I have added it so that I don't have to keep referring to the quick start guide. On the base of the booster is the model number, serial number, Wi-Fi CERD, Wi-Fi key, and booster login details. You will need these if using booster with a non-compatible modem. The booster will only connect via Wi-Fi to a Telstra Smart Modem Generation 2 or Generation 1.1. The booster can be connected to non-compatible modems by connecting its Ethernet port to a LAN port on the non-compatible modem. On the back of the booster there is an on-off button, an Ethernet port that can be used for either connected a wired device or connecting to a LAN port on the modem. There is a WPS button for connecting Wi-Fi devices using WPS or for pairing of booster with modem. There is also a reset button. Once front light has turned red, booster is ready to be paired with modem. To pair booster with the modem, press the WPS button, the back of booster. Front light should flash orange indicating booster is ready to pair with modem. Press pair button on back of modem for at least 5 seconds. Wait for the front light on the booster to turn steady blue. This will take about 3 minutes, so we'll speed this section up. The light might turn steady blue and then start flashing purple before turning steady blue again. So be patient and wait at least a minute before moving booster to required location. If you run into any problems, just press the reset button located on the back of the booster. The front light will go off and then turn purple. It will then pulse blue and eventually turn red. This takes about 2.5 minutes, so have speed this section of the video up. Booster has reset. We'll now set up the booster again and then do some performance testing. This test uses the Wi-Fi mapping tool in the Telstra Home Dashboard app to generate Wi-Fi heat maps of my premises for both the 2.4 GHz Wi-Fi band and the 5 GHz Wi-Fi band. The 5 GHz Wi-Fi band heat map shows a large improvement in the Wi-Fi coverage. The 2.4 GHz Wi-Fi band only shows a slight improvement in coverage. The next few tests measure the speed of the Wi-Fi link with and without the booster installed. The measurements were taken near the modem and in the room with worst Wi-Fi coverage. The first test uses the Wi-Fi Speed Test Pro app by Zoltan Pelagi to measure the Wi-Fi transmit speed from the device. This test gives a reading of the Wi-Fi physical rate, the receive signal level, latency, and transmit speed. For the next test, iPerf3 server was connected by LAN cable to the modem. The Anality iPerf3 client installed on a Samsung Galaxy S9 was used for taking the measurements. This test measures the true rate at which data is transmitted and received over Wi-Fi link. The app displays download speed, upload speed, Wi-Fi physical speed, both maximum and minimum, plus ping echo. The Wi-Fi physical speed is the theoretical maximum speed of the Wi-Fi link at that location. It will depend on the Wi-Fi signal level plus the type of modulation used. The actual speed of the link is usually much less than the physical speed due to overheads and retransmissions. The ping echo is a measure of latency. Here is a graph of all the performance test results, which show the booster has improved the performance of both the 2.4 GHz Wi-Fi, and to a much greater degree the 5 GHz Wi-Fi. The next test measures the performance of the booster's LAN port. An iPerf 3 speed test was carried out using an iPerf 3 client installed on a laptop connected to the booster's LAN port. Although the booster has 1 gigabits per second LAN port, the result was a disappointing 300 megabits per second. The next set of tests measure the performance of booster setup as an access point, with its Ethernet port connected to modem's LAN port. Surprisingly, the 2.4 GHz Wi-Fi transmit speed was lower with booster as access point than transmit speed obtained with booster as Wi-Fi range extender. The 5 GHz transmit upload speed has increased by 30% over the speed obtained with booster as range extender. The 2.4 GHz Wi-Fi true download speed was also lower with booster as access point than speed obtained with booster as Wi-Fi range extender. The 5 GHz true upload speed has increased by 30% over the speed obtained with booster as range extender, but the download speed was virtually the same. Here is a graph of the results. The measurements show that when booster is used as access point, there is a 30% increase in 5 GHz Wi-Fi speed, but virtual no improvement in 2.4 GHz Wi-Fi speed. The lower 2.4 GHz transmit speed could be due to the booster changing from channel 11 to channel 1. There are only 2 brick walls between booster and modem. The difference in speed might be greater if booster had been located further from modem. One flaw with these boosters is lack of customization. Once set up, the booster's graphic user interface cannot be accessed. The modem sets the booster's Wi-Fi name and password to the same as modem's Wi-Fi name and password. The only thing that can be changed is the booster's name and front light brightness via the Wi-Fi booster tab on the modem's home page. The other main flaw is the booster uses the same 5 GHz channel for its connection to modem as is used for devices connected to the booster or modem. This results in the maximum Wi-Fi speed being halved. This should not be a problem, as most devices are not capable of Wi-Fi speeds of 850 megabits per second, let alone 1733 megabits per second. Despite these flaws, the boosters, at $288, still represent good value for money, especially when you consider they include a free upgrade to a Telstra Smart Modem Generation 2 and up to 3 extra boosters if required. The boosters are easy to set up and improve Wi-Fi coverage significantly.